Okay, we are on page 29 of the packet. We're doing the warm-up retrieval section, and it's just a graph matching. So check this out. State the y-intercept of each graph. And so the y-intercept is going to be this dot right here where it crosses the y-axis. And so we've got this graph over here and this graph right here. So the y-intercept of this first graph we see is at 0, -3. Remember that by definition, the y-intercept is when x is equal to 0. So this has to be a 0, and then the value goes in the y section. Okay, let's go get the y-intercept of the other one. This y-intercept is also at 0, -3. And this y-intercept is at 0, +3. You see it right there? So check this out. Over here we have a +3, a -3, and a -3. So we're just trying to match which one goes with which. So for sure, the one that has the +3 is this guy over here. So this first equation A, this one has to go with the one with the +3. So it's y equals x squared plus 5x plus 3 because it's an upwards facing graph and it has the correct y-intercept. So now that we used this one, we're just deciding which one is for B and which one is for C. And one graph is up and one graph is down. Here's my up graph, and here is the down graph. So this down graph has to be B. Y equals -x squared plus 5x minus 3. This one was already with A. And then this one has to be C. Y equals x squared plus 5x minus 3. And that's it. We match the equations based on the A value and based on the y-intercepts. Now find the indicated values for g of x. So it's having us plug in a 2 everywhere that there's an x right here to this equation. So -2 squared. I'm actually going to do this work here further left. Hang on. Just so we have enough space. So -2 squared plus 5 times 2 minus 3 equals -4 plus 10 minus 3 equals 6 minus 3. So there we go. Now g of 5, -5 squared plus 5 times 5 minus 3, -25 plus 25, or 0 minus 3. So g of 5 equals -3. So g of 2 equals 3, and g of 5 equals -3. We plugged in our values and got our outputs. Last but not least, down here is a g of -3. Okay, so this makes -9. So -3 times -3 is +9, but there's a negative in front. Minus 15 minus 3. So that makes -27 if I add up all those negatives. G of -3, output comes out to -27. So a couple things to remember when doing those ones is to do the exponent before multiply, And for sines, same sign, we add and keep the same sign. And for different sign, we subtract and we keep the sign of the larger. Okay. Next, we're on lesson 2.5 on the jump start, and it's having us graph each of these functions. And this right here is an equals. Okay, so pulling out the important information I need. Do you guys see that the stretch is 2? That means it's going up 2 times faster than the parent. My vertex is -3, -5. Did you remember to change the sign? And it's positive or upwards orientation. So I'm going to be going left 3 and down 5, and then graphing upwards from there. So let's go get our graph ready. Here's my x-axis, here's my y-axis. 1, 2, 3, 4, 5, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to go put our vertex at -3, -5. And from there, we're going up 2 times as fast. Out 1, up 2. Out 2, up 8. Connect your graph. Drawing that line of symmetry. Straight through x equals -3. Also called an axis of symmetry. How'd you do on that graph? Let's go peek at the next one. Identify your key features. Stretch this time is still 2, but orientation this time is down instead of the last one was up. Vertex is 3, 5. Go get your graph ready. One, 2, 3, 4, 5. Go put that vertex at out 3, up 5. And then grow down at a stretch of 2. So out 1, down 2. Out 2. Down 8. Connect your graph. Drawing your line of symmetry. Straight through x equals 3. Okay, so those were just our warm-up graphings. Let's go see what this lesson is about. Optima's niece Jenny works in the shop. Yep, we're still talking the quilt shop. Taking orders and drawing quilt patterns. When the shop isn't too busy, Jenny pulls out her math homework and works on it. One day she's working on graphing parabolas and notices that the equations she's working on look a lot like the order for a quilt block. For instance, Jenny is supposed to graph this equation, but she thinks that's funny. That would be an order where the length of the standard square is reduced by 3, and then we add a little piece of fabric that has an area of 4. So it's the x minus 3 squared, and then add a little piece of fabric that's got an area of 4. Fully describe the parabola that Jenny has been assigned to the graph. Well, we could say it has a vertex at 3, 4. It has a stretch of 1. Its orientation is up. And when it has the growth rate of a stretch of 1, it's the same growth as parent graph. Means it goes out 1, up 1, out 2, up 4, etc. So Jenny returns to her homework, which is about graphing quadratics, and much to her dismay, she finds that she's been given this one. I don't know where the vertex is. I can't identify any of the transformations in this form. So what am I supposed to do? But then she remembers that this is the area of a perfect square. Well, not quite. Oh, wait, yes, it is. Use your work from lesson 3, building the perfect square, to answer the question and justify the answer. So, could we rewrite this as a perfect square? And we notice that this one could be built as the x minus 3. Perfect. Jenny says, I think I figured out how to change the form of the quadratic so I can graph the parabola. I'll check to make it into a perfect square. So we just did that. So here we go, y equals x minus 3 squared. So find the vertex and then graph the parabola. So my vertex is hk, or h of 3, comma 0, because there's no number here added to the end. Let's go graph this parabola. Okay, so go put that dot at 3, 0. This is the x minus 3 squared graph. So my vertex is 3, 0. It's got a stretch of invisible 1. So it means it's growing upwards at the normal rate of a parent. So out 1, up 1. Out 2, up 4. And out 3, up 9. Connect your parabola. And then draw in that line of symmetry. Straight down with the equation x equals 3. Jenny had hoped that she wasn't going to need to figure out how to complete the square on an equation where b is an odd number, but of course that was the next problem. Help Jenny to find the vertex of the parabola for this quadratic equation. All right, so we want to make a perfect square, and we've got this 10 in the way. So we're going to bump that 10 over for a second, and we're going to do this work here on the 7x. So half of 7 is 7 halves. 7 halves squared is 49 fourths. I just did this work over here. b over 2 squared is 49 fourths. If I add 49 fourths to the equation, I need to subtract 49 fourths to balance. This makes my perfect, or the x plus 7 halves squared perfect. And then I just need to simplify this at the back. 10 could be rewritten as 40 fourths. And so we get 40 fourths minus 49 fourths. So it simplifies down to negative 9 fourths at the back. How'd you do? Okay, if you had to think hard about problem 5, she needs to do a couple more, so go for it. So we go x squared minus 5x, make some space, bump that 3 over. Half of 5 is 5 halves. 5 halves squared would be plus 25 fourths. So we minus 25 fourths for the adjustment. Final answer, g of x equals the x minus 5's halves perfect. And then 3 could be rewritten as 12 fourths minus 25 fourths. So that's going to become negative 13 fourths at the end. All right, get this one ready. The x squared minus 1, or invisible 1x. I'm going to bump the negative 5 over so we can leave space to complete this square. What's half of 1? You're right, 1/2. What's 1/2 squared? 1/4. If I add 1/4 to this, I need to subtract 1/4 to balance. This makes the x minus 1/2 squared perfect. And then 5 could be written as 20 fourths. So negative 20 fourths minus 1/4. Our adjustment's going to be negative 21 fourths at the very end. How'd you do? So this is the equivalent expression for this guy, and this is the equivalent expression for this guy. It gets better. Help Jenny find the vertex and graph the parabola for this one. Oh no, we've got a big fat 2 in the front there. Check out the steps for this one. Step 1, we make space by bumping the 17 way over. Now we need to make one square to complete the square on it and then pull that 2 out. So we divide it out of 2, leaving us x squared minus 6x in these parentheses here. So now let's go do our b work and complete the square. Negative 6 divided by 2 is negative 3 squared. So we're adding 9, but we're not just going to add 9 one time. We're adding 9 2 times. So to balance, I subtract 9 2 times. And this creates the 2 quantity x minus 3 squared. And this reduces down 17 minus 18 to just negative 1. Here's my equivalent expression for this guy right here. Yay! All done.